Okay, let's discuss the improper rational function part. Under the improper rational function part, this is the first section. Both degrees are equal. So it is, we can call it is the improper rational function. Improper rational function means numerator, degree of the numerator less than, greater than or equal degree of the denominator. We can call it is the improper rational function. So in this section, both degrees are equal, so we should put the constant to initial part a. After that we can separate using this denominator parts, x plus 2 plus x minus 1. The degree of this part is 1, so this would be a 0 degree term. It's called capital B, because before we put the capital A to initial stage. This degree is 1, so this will be another constant. After that we can multiply both sides by this denominator. X squared plus 5 equal a into x plus 2 into x minus 1 plus b into x plus 2 cancelling, only rest is x minus 1 plus c into x minus 1 is cancelling, so x plus 2 is the rest part. X squared plus 5 equal a into x squared minus x plus 2x equal plus x minus 2 plus bx minus b plus cx plus 2c. X squared plus 5 equal ax squared plus ax minus 2a plus bx minus b plus cx plus 2c. Then we can factorize using similar terms. X only x squared only one x squared term it is ax squared. There are three x terms, ax, bx plus cx, so we can factorize like this: a plus b plus c into x minus 2a minus b and plus 2c. It's a constant. These are constants. So after that we can compare the corresponding coefficients. We can use the corresponding coefficients. X, when it comes to the x squared part, only a equal, this coefficient is 1, the first one. When it comes to the x part, a plus b plus c, there are no any x part, so it's equal to 0. We can simplify it because already we know a value is 1, so we can put this from 1 plus b plus c equals 0, then we can call b plus c equal minus 1. When it comes to the constant part, minus 2a minus b plus 2c equal 5. A is 1 minus 2, and substituting 1 from 1 minus 2 minus b plus 2c equal 5. When go to the minus 2 to other side, 2c minus b equal minus 2 become a plus 2 plus 2 plus 5 equals 7. This is the second equation, this is the third equation. So we can add second and third equations, then plus b and minus b is cancelled, will be cancelled. So 2 plus 3 plus b minus b will be cancelled, so c plus 2c equal 3c. 3c equal minus 1 plus 7. 3c equal 6, then c equal 2. When dividing both sides by 3, c equal 2. From equation 2, from second equation, we can write b plus 2 equal minus 1, then b equal minus 3. So we can write the partial fractions of x squared plus 5 divided by x plus 2 into x minus 1 equal a equal 1, b equal minus 3. So we can put the minus symbol to this place, and 3 over x plus 2 plus c equal 2 over x minus 1. These are the partial fractions of this improper rational function. Okay, let's discuss the second question under the improper rational function part. Let's see how to solve this improper rational function to partial fractions. So initially we have to look at the decrease of the denominator and numerator. The degree of the denominator is 2. The degree of the numerator is 3. So you can see the numerator degree is greater than the denominator degree. That's mean this is the improper rational function. So we have to look at the difference of these. If numerator degree is less than the denominator degrees, we don't need to look this part, but numerator degree is greater than the denominator degree, we have to look at the difference of these degrees. 3 minus 2, difference of these degrees, 3 minus 2 equal 1. So we have to put the general function, general term, the difference, the degree difference of these numerator and denominator. The difference is 1. What is the general function of the degree of 1 degree term? We can call it ax plus b. After that, we can write x plus 3 plus x plus 2. So after that, now we can solve this part like previously. This is degree is 1, so this would be a constant because the degree is 0 terms. C, this degree also 1, so it will be the constant d. So now we have to find a, b, c and d. Let's see. Firstly, we have to multiply both sides by this denominator. X cube plus 2 equal ax plus b into x plus 3 into x plus 2 plus c into x plus 3. We can cancel x plus 3 and x plus 3. Only rest is the x plus 2 plus d into x plus 2 is cancelling. So x plus 3 x cube plus 2 equal, I am keeping these terms like previous, but I am going to solve these two terms. X into x cube squared, 2x, 3x, 2x plus 3x equal 5x, 3 into 2 equals 6, plus cx plus 2c plus dx plus 3d. So x cube plus 2 equal, now I am going to multiply ax plus b into this part. Ax cube 5ax squared plus 6ax plus bx squared plus 5bx plus 6b equals cx plus 2c plus bx plus 3b. Now I am going to factorize similar terms. Only we have x cube, one x cube term, ax cube plus there are two x squared terms, 5a plus b into x squared. There are 4 x terms, 6a plus 5b plus c plus d into x. There are 3 constants, 6b plus 2c plus 3d. Okay, now I am going to compare the corresponding coefficient. Initially I am going to take x cube coefficients a equal 1. This is the first equation. When it comes to the x squared terms, 5a plus b equal, there are no any x squared terms, so coefficient is 0. So we can substitute from 1, 5 into 1 5, 5 plus b equals 0, so b equal minus 5. When it comes to the x terms, this is the second equation. 6a plus 5b plus c plus d equal, there are no any x terms for 0. So we know the a and b value both a and b values. 6 into 1 6, minus 5 into 5 equal minus 25, plus c plus d equals 0. C plus d plus 6 minus 25 equal minus 19. So c plus d equal plus 19. This is the third equation. When it comes to the constants, there are three terms: 6b plus 2c plus 3d equal 2. From I have substituted from 1 and 2, so I will write 5 from 1 and 2. There are only b terms from 2. 6 into minus 5 equal minus 30 plus 2c plus 3d equal 2. 30, go to the other side, plus 30. 2c plus 3d, 2 plus 30 equal 32. This is the fourth equation. So we can subtract after multiplying third equation by 2. 3 into 2 minus 4. 2c plus 2d minus 2c minus 3d. 19 into 2 minus 32. 2c cancel. Minus d equal 19 into 2 38. 38 minus 32. Minus d equal plus 6. Then d equal minus 6. So now we know the all a, b, c and d values. So we can write the partial fractions of x cube plus 2 divided by x plus 3 into x plus 2 equal a is the 1 in on the x, b equal to minus 5, x minus 5 plus c equal, c is, we didn't find the c yet, so I'm going to find c from the equation 3. From the equation, c b equal minus 6 equal 19. So c equal minus 6, go to the other side, plus 6 equal 25. So c equal 25 divided by x plus 3 plus d equal minus 6. So I can write the minus 6 over x plus 2. These are the partial fractions of this improper rational function.